Hi everyone, I am Sasang from SRM University, and today I will be talking about something really important in today's digital world, that is privacy preserving data warehousing, and especially how a powerful tool called homomorphic encryption helps us keep data private and even when we are working with it. Let's look into this. So first we will understand what is a data warehouse. So it is a central place where all organizational data is stored. So it collects data from different sources like sales, customer feedback, or even from sensors. The goal is to analyze the data and make smarter decisions. For example, a retail company might use a warehouses to track sales across different months and improve its marketing strategies. So it's not about storing data, it's about seeing the big picture in it. And data warehousing, it is the process of construction and maintaining of the data warehouse. So in data warehouse the data will be stored in a summarized manner. And why privacy is more important in warehousing? So, as we discussed, data warehouse contains information from different sources. So, it can include sensitive data like personal information, like our name, address, phone number, and even our financial records, medical histories. If it is a healthcare department like a hospital, if there is no any privacy precaution is not taken, then there might be risk issues like data breaches. Data can be breached out to the others. And unauthorized access, someone can hack our systems and see the sensitive data, which will be a legal issue. And loss of trust, if business will be collapsed. So we must protect data even when it's being analyzed. So it is one way for to protect the data. So how can we protect data when it's been analyzed, when it's been encrypted? So we will look into this. And here's our solution: homomorphic encryption. So it is a cryptographic technique that allows computations to be done on encrypted data. So unreadable format ciphertext, which contains a combination of symbols, letters, and numbers. So without requiring the decryption of data, we can perform the actions on it and decrypt the data, and we can see our results. So homomorphic encryption lets you to perform calculations on encrypted data and keep data private during processing, get corrected results without ever seeing the raw data. So in a real world analogy, we can imagine you are baking a cake, but the ingredients are locked in a box. Without uh, without the ingredients we can not make a cake. But with homomorphic encryption, we can still mix and bake the boxes. When you unlock the box, we can see a final result, our cake will be ready. So our key idea of homomorphic encryption is work on scrambled data and still get meaningful answers. So in homomorphic encryption there will be two keys. One is public key, that is for the encryption, and the other one is private key, that is for the decryption. So how it works in data warehouses? So first, the data encryption. Before entering into the warehouse, the sensitive data will be encrypted and stored in the warehouse. And the next step, encrypted computation. Analysts run SQL queries on or aggregate functions like sum, average, multiplications, or any other functions on the encrypted data. And the next step, decryption of results. Only the authorized person, example a manager or the owner, can decrypt the final result. uh, Example, A bank calculates the total loan amount per city, all while the customer's data stays encrypted. So we will look into this. We can see the picture. There is a client. So he's want to and calculate the total loan amount per city of all the bank of a particular bank. So bank contains a very sensitive data of user details like name, email, pass, phone number, and address. So here in data warehouse, the sensitive data will be encrypted first. So the encrypted data will be passed to the client, and the client will perform the sum function, the or the addition function on the encrypted data, and he will sense the he will and he will generate another encrypted data after applying that function, and after that he will ask the manager or the organization owner to give the decryption key, that is the private key, decrypted key, for him to see the results. So after allowing the secret key to the client, he can decrypt the result. So here, without seeing the raw data, he can apply the addition function on the encrypted data. He can see the results, that so the result would be the number of persons having loan in the bank in a particular city. So there are three types of homomorphic encryptions. First one is partially homomorphic encryption. It supports only one type of operation, either addition or multiplication, but not both. So it is good for simple users, like in the previous example we discussed. And the next one is somewhat homomorphic encryption. So it supports both addition and multiplication, but only a limited number of times. So it will be useful for medium complexity tasks. And the other one is very important one, fully homomorphic encryption. Supports unlimited additions and multiplications operations on encrypted data. So it is ideal for bigger problems. So it is more complex, so it will time consuming and slower. Now we will see a real life example. So a company HR wants to calculate the average salary and the salary distribution by department, and to analyze the highest and lowest salary of a particular of his company. So now first, the company will send a encrypted data to the HR. Now HR performs the max, min, or the average functions on the encrypted data. So and after performing the operations on the encrypted data, he will ask the owner to send the private key to him, to allow, so he can see the results. So after permission is given, he can see the result. The final result will be like, this is the highest salary and the average salary will be like this and like this. And moving on to the conclusion, homomorphic encryption is a revolutionary step in data privacy, perfect for the data warehouses, cloud based, and privacy sensitive analysis. So, fields like healthcare and finance industries are already exploring its potential, and with continued development, it would become a standard for securing sensitive data in data warehouses. This technology not only addresses the current privacy concerns but also aligns with the growing demand for secure and data driven decision making. So it also complies the GDPR and HIPAA HIPAA guidelines. Those are the General Data Privacy Regulation and the Health Insurance Portability and Accountability Act of European states. And the future seeing towards the fast and efficient and widespread of FHE, that is fully homomorphic encryption in everyday data analytics. And my closing statement: with homomorphic encryption, data stays locked even while it works. Thank you.